In this video, we are going to cover the IPv6 address types, and there are quite a few of them, so it's pretty much just kind of demands its own video. And there's not a lot of what's the word I'm looking for? There's not a lot of carryover from or parity between IPv4 address types and IPv6 address types. So there are going to be, like, you're going to have your public IP address range, which is going to be similar to your global unicast. You're going to have your link local addressing, which is going to be like your link local addressing in IPv4, which is the 169.254. And then you're going to have your loopback. Obviously, you're going to have your RFC 1918, which is going to be like your unique local. So there are some similarities between the two, but the way that they're identified is differently. And things like that. So we're going to talk about how that covers as we go through, and that's pretty much going to be the end of our theory for IPv6. Because once we get into that, once we're past this point, then it's going to be, okay, well, let's actually get on the router, let's actually take a look at how this is configured, and then get into the meat and potatoes of how this actually gets put together. And once we get there, we'll have, we'll do an OSPF setup, get that rolling. We'll do an EIGRP setup and get that rolling, and then we'll get BGP set up. And that'll definitely be very helpful for all of you to see how OSPF, EIGRP, and IPv6 or BGP all work together, and then get some routes advertised and see exactly how that comes into play, and how you different things you can manipulate. And we're going to be working with the specifics for like named mode, and I'll show you guys some of the details for that. But realistically speaking, it's pretty simple to work most of it, so I wouldn't get too too hung out. There's multiple ways of doing the same thing, and I'll show you how the differences and stuff like that. So if you, like I mentioned in the previous video about the RFCs, 4291, the IPv6 addressing architecture, specifically section 2.4, is address type identification. And depending on how which address you're looking at, how the address is notated to you will be determined by the high order bits in the address. What that means is, if you took a look at the top 10 bits of each address, depending on which ones you're looking at, will tell you what exactly the address is telling you. Now, if you understand what the bits are. So as we mentioned in the previous video when we talked about how the breakdown of the nibbles and our, because every, for instance, when we have this this FE80 here, we have FE, so this is F, this is E, and this is a 10. So it's 1 0, because you don't have to carry the other zeros, so you drop them, and then the last 0 is carried right here. So the first 10 bits are all that matters. So as you're breaking this down, it's important to remember what each address type means. So the first one we're going to take a look at is link local address. And the link local address is going to be used per interface. And the nice thing about this is that if you want to make it easy to identify on a per router basis, on a per interface basis, when you're doing your local IGP routing. When you're doing IGP routing inside your network, what you actually get for the next hop is going to be a link local address. And that is going to be how you recurse to your next hop in IPv6. Or if you're looking at this from the global unicast perspective, your next hop is going to be a global unicast address. So as we're going through, you'll see how this stuff actually gets broken down, and the details of how it actually gets propagated. And it's actually kind of interesting how they put the protocol together. FE80 : anything is link local. So FE80 : 2, it doesn't matter what the address is. If it's FE80 anything, that's link local. And that is not routable between your interfaces of your devices. Whether it's a router, a switch, a firewall, it doesn't make a difference. As long if it's FE80, that is going to be link local. Now, some of the cool things about that is you can take your every interface of your router and you can type in IPv6 address FE80::1, and you can type in link local at the end of that. So that would be your command, IPv6 address FE80::1 link local. That would be the command you would enter. And what you would do is you do that on every interface of that router, so that when you are going to the next hop and you type in, so let's say router 1 connects to router 2, and you just typed in IPv6 address FE80::2 link local. Well, what's going to end up happening is that is going to be the advertised address to the next hop to determine how the next hop reaches you. So if router 1 wants to reach router 2, and you've configured router 2 with the FE80::2 on the same interface, the same link to get to router 1 is going to see the next hop as FE80::2, because that's what is being advertised via neighbor solicitation, neighbor advertisement, in your router advertisement to router 1 from router 2, saying if you want to get to me, this is how you get there. As long as you have a route to it and you know what interface to leave out, you're golden. That's the idea of link local addressing, and it's very beneficial in that regard. A couple of the other things too, it's also used in Slack, so stateless auto address configuration, which is I'll say a variation of DHCP, so that if you're familiar with DHCP, that'll give you a kind of it helps in that regard, but it is not the same thing as DHCP, so don't get the two confused. And I'll talk about how this works much later on. We'll cover some of the IPv6 variants to the services as we go through. And then we have the site local address. Now, site local address was actually deprecated, so it's no longer used. But if you were to see this in an exam, if you saw FEC0::10, or : anything really, that is going to be site local. Now, again, it's been deprecated, and the primary reason is no one could agree on what a site is. So, just for kicks and giggles, in the last class I had to teach, I asked everybody, so what do you consider a site? And do you consider say for instance, like, I don't live too far from the University of Wisconsin-Milwaukee. So if you are familiar with the Milwaukee or Chicago area, if you go down to like the University of Chicago or University of Illinois, I think they have a location in Chicago. So anyway, if you go to a college campus of any major college that's out there, more than likely they're going to have more than one building on the campus. It's going to be a collection of buildings to make up the campus. Well, do you consider that a site? Or do you consider an individual building on the campus a site? So nobody could agree on that perspective. So they decided to remove that designation and go with the unique local. Now, the unique local is going to be pretty close, pretty much in comparison to RFC 1918 space. So what does that equal? Well, it's going to be your IPv4 IGP internal addressing, so your 10.172.16 or 192.168 addressing. So that's where that comes into play. Now, ULA is private using IPv6 addressing. So as you can go through, you can do, say for instance, on the internet edge. So if whether it's BGP or you're just receiving a default route from the provider, you can actually go in and run FC00 whatever you'd like, and then be done with it. I mean, that's pretty much really all there really is to it, and to get it operational. So it's pretty straightforward for the most part to get it operational, and literally you're just typing IPv6 address and then FC00. Now, what your designations are is up to you. You can use a lot of times, a lot of companies that I've worked with that have deployed IPv6 in like a test environment for testing, like I mentioned in the previous video, you're typically going to, and this is what they did, they actually took the IPv4 address and they pretty much just inserted it into the IPv6 address, and then there you had it. So then all you're doing is you're adding a prefix, an IPv6 prefix, and you're swapping out the dotted decimal for a colon designation to separate the octets. That's all you're doing, /64. So that's all there really is to it. And a lot of companies I know that have done test environments are doing that. More and more companies are moving to IPv6. Is there a real big push or need for it right now? I would say no. At the current point in time, it's my understanding that the if you are going to if you have to deploy IPv6, there's usually a international routing need for it, meaning that you have a site in the Europe, like the EMEA or the APAC region, that only can get IPv6, and you need to run it just for that. But most cases, companies in the U.S. don't deploy IPv6. I know there's some service providers that are actually deploying it and stuff like that, but at the end, it's one of those things where it really doesn't make any difference. But it's up to the individual company. But I'm not going to go really any more in detail on that part. So that's unique local. Then we have the global unicast address, and I'm not going to go into super detail on each one of these. I'm just going to kind of give you a high level overview. The global unicast is going to be literally everything else. So right now, IANA, or the Internet Addressing Named Internet Assigned Numbers Authority, I think is what IANA stands for, currently allocated 2000::/3, which is a very large address space to begin with. However, it is also a very small portion of the overall scope of addresses that are out there. So right now that's actually 2000 through 3FFF. Now, this documentation is just a touch dated, so I think it's about a year or two old now. So it could be that could have changed since then. And I put this document together about 18 months ago, and so it would have been like right around Christmas of 2014, or New Year's of 2014. So right around the time I passed my CCNP. So we have that. Now, per the RFC, end hosts, when it comes to global unicast addresses, must have a 64-bit interface ID. So that doesn't change. So we have that piece in there, and as long as that's in there, you're okay. And realistically speaking, I never have a problem with that. And every one of the addresses that I've placed in here are going to be /64 anyway. I don't play around with doing /20 127s and stuff like that. If I was planning on doing an IPv6 series, I would definitely go into a lot more detail on that, but I don't think it's really needed for the exam. So just kind of go with it. There's a question: can you run IPv6 on a Cisco switch? I honestly don't know. I don't believe the code that I'm running here at home supports it. I think you have to be on 15.x code or higher on the switches in order to support that. But I could be wrong. I would actually have to... I'm actually looking at my rack of equipment right now. I have a 3550 that's operational that I could console into and take a look, but we're going to be getting into CCNP switch here pretty soon, and I could take a look, but for right now I'm just going to go with no, because in my experience I haven't been able to get it to work, and I didn't, honestly, when I was studying for my CCIE, which I haven't earned my CCIE, when I was still, I'm in between my second and third attempt right now, because I did fail my second attempt, but I was like right on the border of passing. I passed all 3 sections, but I failed the overall. So there was parts of it like IPv6 first hop security, some more of the advanced level IPv6 that we're not going to be getting into here that I had to study. That stuff right there was only covered in 15.x code. So, but I'm going to go with no right now. If you want to go out there to check it out, I don't believe it's supported on 12.2 for Switch, because that's what I have is 12.2. But it's relatively, it's kind of pointless at this point. So that's basically how that would break down. And as you can see, that's the numbering breakdown is the network, and then you have the host. So if you'd like to know more about that, I would definitely check out the RFC and take a look at some of the other. I've gone into a lot more depth on this in my CCA series, So if you want to know more about IPv6, definitely check that out. I go into much more detail on it. I just don't think it's needed here. And then we have the modified EUI, or extended, what does that stand for? I'm looking at my page. I honestly forgot what. Extended Unique Identifier, I think is what it stands for. But anyway, basically what EUI does, and basically EUI is a way for you to take an address, and you're going to take the 48-bit MAC address, it's the burned-in address on the interface, and you're going to take that, and you're going to take it, split it down the middle, so the first 24 bits are the OUI, or the Organizationally Unique Identifier. This is what the vendors get allocated from the powers that be, so the standard bodies, and they're given. So Cisco might have, has a range of MAC addresses that are specific to it. So if you were to copy and paste the MAC address, the first half into a online tool, it would tell you who the vendor is. You could take that first half, and the back half is randomly generated by the vendor, and then it's burned in. So if you were to take that address and split it down the middle, so the most significant bit, the first 24 bits, and the last 24 bits, if you were to break that bad boy in half and shove a FFFE in between them, you would be able to stick 16 bits of padding. So you're taking that 48-bit address and making it a 64-bit address. That's what EUI does. Now, what they mean by this inverted universal local bit, the 7th most significant bit, the idea behind that is if the bit is turned on when the address is configured, EUI is going to flip that to off. So whatever it is, it's going to be the opposite once it's said and done. The 7th most significant bit, that's going to be the second nibble, the 3rd bit, or the 2-bit that I showed you earlier. It's going to be the 2-bit. If that bit is turned on, to where, like, if the IP address has a 2 in it, then that's going to get flipped to a 0. So it's going to get turned off. And therefore, then, too, if it's turned off, EUI will turn it on. So it'll be flipped over to 2. So your MAC address that you see at the interface level might be slightly different post EUI configuration because of the fact that that 7th most significant bit, it got turned on or off depending on how the original address was set up. So don't freak out if you see that, if it doesn't quite match up, but if it's like almost spot on but not quite spot on, then you know EUI is there. And it's really easy to configure it. All you have to type in is the address and then type in EUI, and it will snatch the so for instance, you would type in the subnet mask, or you would type in the network portion, and EUI would just basically tell the router, okay, whatever the MAC address is, go ahead and snatch that bad boy up, stick it at the back half of my address, and just be done. That's basically what you're saying. Now, I'm not going to go into a ton of detail on these next ones. For like the temporary address, this is used to prevent spoofing of networks and stuff like that. That's basically what it is to prevent tracking users based on MAC address. Basically, it just randomly generates a MAC address, but that's just kind of an additional feature. Now, when it comes to address resolution, this is one of the ones I want to spend a little bit of time on, and I'll get into some of the other details here. When it comes to address resolution, ICMP, or I should actually say ARP, so the Address Resolution Protocol in IPv4, has been done away with and renamed to ICMPv6 ND. Basically, what that's designed to do is it does exactly the same thing as IPv4 ARP does. It maps layer 3 to layer 2. Now, why is that important? Well, let's think about this for a second. If you watch the route video where I talked about, how does a router route? On the broadcast multi-access interfaces, what's going to end up happening is there could potentially be more than one destination IP address reachable out that interface. So what you're going to do is you're going to go out and you're going to say, with ARP, he's going to go out and say, hey, I'm trying to reach this IP address. I needed to know the layer 2 address to map to it, so I know who to send the traffic to. Well, he's going to go out there, he's going to send an ARP, and he's going to say, whoever is 10.1.1.1, please respond with your MAC address to me. So an ARP goes out, an ARP response comes back in, the MAC address, the layer 2 header is filled with the MAC address that's populated in the CAM table. You're good to go. Or in this case, it would be the ARP table. So, because the CAM tables are on switches, ARP tables are on routers. So you have that. Everything's good to go. You're golden at that point. Now, that's basically what ICMPv6 does as well. They do the exact same thing, it was got termed differently. So ICMP, or the Internet Control Message Protocol version 6. Now, when it comes to the different messages, we have the neighbor solicitation, which is the ARP request. Hey, I need to know something about you. And so, like, you come up to me and you're like, hey, are you Rob? I do a lot of consulting and I meet customers and stuff like that, and out at restaurants a lot. And I'll be wearing a blue, button-down collared shirt, just in case you're not sure who I am, or you check me out on LinkedIn. Maybe they don't have time to, but I'll give them that. They'll be like, hey, are you Rob? Which is the solicitation. And then I'll respond with, "Yep, that's me. How you doing?" And that's my reply. That's how you get to know each other. Then you have, that's for neighbor solicitation and neighbor advertisement. That is for your adjacencies, and we'll talk about that more in detail as we go along. But that's how you get to know everybody on your network. Now, once that's said and done, we also have the router solicitation and the router advertisement. Now, the router solicitation is sent by IPv6 hosts to discover the presence of IPv6 routers on the link. Again, it's like an ARP. Hey, who's out there? Who can I talk to? And then advertisement is, hey, I'm right here. Not to be mistaken with the gratuitous ARP. Now, what's a gratuitous ARP? Well, gratuitous should be the key word in that comment. Gratuitous was the gratuity. Now, if you're in the U.S., we have a thing called gratuity. I don't know if it's anywhere else in the world, but in the U.S. we have a thing called gratuity. Gratuity means that you are going to pay extra for the services you just rendered. Meaning, if you go to or I should say, you're going to pay for services that were rendered to you, I should say, not services you rendered. Rendered means that you received. So, if you go to a restaurant here in the U.S. and you have a waitress or a waiter come to your table, take your drink order, and then they take your food order, and they go to the kitchen, they put it in there, the cooks make the food, and then the waiter or the waitress brings the food to you. Once you're all said and done, they bring you the bill, and they say, okay, this is how much we're going to charge you to sit here and eat our food. On top of that, normally it's 12 to 15%, depending on what city you live in. You're going to have to pay gratuity, a tip. You're going to have to say, hey, this is what you're going to get. A gratuitous ARP does something similar to that. It's going to say, hey, this is me. This is what's up. How you doing? If you want to get to me, this is how you get there. So it's not exactly the same thing, but it makes sense to some degree. So you're going to be giving more than what was expected. So that's kind of the whole thing. A tip is more. You're giving that waiter or waitress a bonus for their time and effort, because they had to come to you, and maybe you were crabby or crabby. That's a Midwesterner's term for you were upset or you were mad, having a bad day. But anyway, if you are, and I say Midwesterner, I've heard some people from New York use the term crabby too. My wife uses the term crabby on a pretty regular basis when my kids start bothering me. I'm like, Daddy's gonna get crabby. That's just how we refer to getting upset. I love my kids and I love my family. But anyway, that's gratuitous ARP. The gratuitous ARP says, hey, this is me, this is how you get to me. So but this also can be a bad thing too. A gratuitous ARP could also be a security vulnerability, saying, hey, instead of going to him, come to me. Man-in-the-middle attacks are notorious for using gratuitous ARP. But we're not going to get into that in this series. That's a security series that's long down the road. So, now that I've discussed how some of this stuff works, and you can read your screen, and it's been sitting there for a while, this information will be posted online. So don't freak out if you haven't if you're not sure you're going to get it all. Then we have SLAC, Stateless Auto Address Configuration. What does that mean? Well, it automatically assigns an IPv6 address for every on-link prefix. Only works with /64 links and does duplicate address detection to verify uniqueness of a generated address. Okay, what does that mean? Well, here's how this works. What is DAD? Well, DAD is duplicate address detection. What you're going to do is you are going to, on your local link, so this is going to be either on either a switch network or on a point-to-point, more likely a point-to-point. What you're going to do is you're going to basically gratuitous ARP. This is why I bring this up. Is you're going to go on the link and you're going to say, "Hey everybody, I want to use this address." And if anybody responds to that message and saying that they already have that address, that's where the duplicate address part would come into play. If anybody responds to that message that you just sent out on the link, you can't use that address. You have to use something else. But at least you know you can't use that specific address. You're going to populate your source as an unfilled address. Basically, it's just going to be it's empty space. Colon. It's just a filler for the most part. It's all zeros actually on IPv6. Colon is all zeros. So you have that part to look at. Now, you do that, and if the DAD comes back and says, okay, no duplicate address detected, so DAD passes and lets you go through and do what you got to do, and then from there, you're able to go ahead and apply that IP address to your interface, and you're good to go. Now, that's how SLAC works. SLAC is not DHCP. It does not include options. All SLAC does is it allows you to associate an IP address to your interface. That is it. DHCPv6, however, on the other side, is what allows you to add in the options. Now, here's where it gets. This is the specifics here. This is what they refer to as the M and O bits, or the other config or managed config. Now, the other config means you just received the addressing. So, additional features like DNS. Use these to receive just addressing options. Having lost my train of thought. So with SLAC, you're just getting an address. You don't get any additional there's no additional information sent to you. With the other config, you use IPv6 to just the addressing options. So DNS, TFTP. So you're going to need a DNS address, a TFTP, and there's a question: why would you need TFTP? Simple. If you are doing voice over IP, you're going to need to know the TFTP server to download your phone config. Now, a lot of the companies I work with are actually moving away from the IP telephony capability, and they're going over to what they refer to as SIP. And SIP is basically turning your desk phone into a cell phone. So it's going over the network, and there's no local call server. It's all going out over the internet. It's kind of, it's kind of hinky. I don't really care for it too much. I've ran into a lot of problems in networks with SIP. It's pretty much got to be, your network's got to be ready to support SIP in order for it to just kind of rock and roll. It's kind of plug and play. At least in my experience it is. And then we have the managed config flag. So it uses DHCP for both IP for addressing and the options. So that's basically the idea behind that. I'm not going to go into a ton of that detail. I'll show you guys how to manipulate that when it comes to DHCP. It's very, very simple to do. A handful of commands at the interface level, and that's pretty much all there really is to it. And then we have neighbor discovery for host default routing. Hosts do not receive default gateway from DHCPv6. First hop IPv6 router deduced from NDRA messages. So what does all that mean? Well, basically, it's true. You don't receive your default gateway from DHCPv6. You receive your default gateway from your first hop IPv6 router. Meaning that if your first hop IPv6 router is going to be, and you have to be careful with this because multiple routers can advertise a default gateway to you. Doesn't mean you actually have to use it, and you can specifically state which routers are going to be your default gateway. It's called a router advertisement. So you're going to neighbor discovery and router advertisement messages. So you can go in there and tell it to not advertise a a default gateway. And the way you're going to see that is going to be an N with a little D, and you're going to see a default or a basically a default route pop in. A default route in IPv6 is a ::/. That's all there is. That's all there is to a : and you type that in, and you're done. That is the extent of the default route, because it's that's all there really is to it, because that's the default route, because you're saying : anything, and you're good to go. So we'll talk about that more in detail. And the general prefix is used as kind of like a macro that once you configure it and you apply it to the interface level, they all inherit that, and then you can just type in the you configure the general prefix. So you type in IPv6 general prefix, you name it, and then you give the prefix here. So in this case, 2001:123::/32. So that's going to be your 32 is going to be your grand address, and then at the interface level, you type in whatever the name of the prefix is, IPv6 address. You're going to type in 2001:123::, and pipe in 1, so you're automatically going to associate on that interface : 1/64. So it's automatically merged to derive the full address, and you're good to go. So that's basically how that works. So what I'm going to do at this point in this video, we are done. Everything's been covered that I want to cover in this video. We will then take a look in the next video at getting OSPF operational for IPv6, getting some routes advertised, and show you guys how that actually works, and then how do you redistribute and stuff like that. Redistribution in IPv6 is slightly different than IPv4, and we'll take a look at exactly how that comes into play coming up. We'll start with OSPF, then we'll move into EIGRP, then we'll bring BGP into the mix, we'll redistribute routes, everything will be golden, and then I'll get into some of we'll begin with the services and security, and we should be wrapping up at that point. But there still is quite a bit of content left for me to cover. The bulk of it has already been done, though. So that's pretty much what's going on. So I hope this has been informative for you, and I'd like to thank you for viewing.